Well, hi, and welcome to my shop here this morning. Hey, today is June 11th, and I've got a few more capacitors to replace in this radio. So I'm just thinking about the order to do them in, and I think I'm going to look at the RF end of this radio. So the RF end. So that would be the RF end, and this would be the audio end down here. So if we look at the RF end, you know, where these coils are, where the front end tube is, and the mixer tube, what do we see? We see one tubular capacitor remaining right there. Now I've done 4 of these capacitors from the radio so far, and all of them have proven to be leaky enough that they warrant replacement. So I shouldn't be too hesitant about doing this one. Let's find this on the schematic and see what it's doing. Let's see if I can look here. It's between pins, looks like 2 and 7. 2 and 7. This is the ground wire, or B minus wire here. One terminal is to the B minus point here. So it's really only hooked up to this terminal, which is pin number 7. So capacitor off of pin number 7. Let's have a look. Okay. Capacitor off of pin number 7. So this must be it here. It's a bypass. So if this were, let's start with leaky. If this were leaky, this would still be leaking as if it's a multi-megohm resistor. So a multi-megohm resistor across a 330 ohm resistor is nothing. So I think a leak in here would be fairly immaterial. The pressure on this capacitor is very low also, because it's just the voltage drop here, and it can only be a few volts. It can't be much more than that. So not a lot of pressure and not a lot of concern. So leakage is not really an issue here. The loss of capacity, and I'm not exactly sure how that happens in a capacitor like this, but if it didn't have any capacity, then it wouldn't bypass this resistor, and consequently the output the output of this tube would then be shared between the coil and the resistor. That's really not what you want. You really want to drive this point down to B minus, AC wise or signal wise, and that will cause all the output to develop across here. Ooh, maybe a little bit here too. I don't know, another bypass. Yeah, another bypass. Well, we'll get to that one. This one says C anyway. It's not a tubular one. It's really this. So this is it. This is it for tubular capacitors in the front end, really. Yeah. I've already done these ones down here. Okay, so we'll go after that one. Can't imagine it's going to make any difference at all. If it were to make a difference, the difference would be the bias voltage, the voltage drop across here. Oh, I can't imagine it changing. Hey, is this really a 330? Maybe that's worth looking at too. Why don't we do that? We'll find the 330, change this capacitor. Okay, the 330. So that would be, well, there it is. I was going to say that would be orange, and there it is there. Orange, brown. And it's right across the capacitor here. So is that really 330 ohms? Put away the schematic. I think I can read this in circuit accurately. .410, so it's higher. So if there's a parallel path and I'm really reading a few components in parallel, then if this resistor were really 330, I would read 330 or less. I can't read more. So the only way to read more, like this has to be at least 410 now. 330, 410, that's, you know, I'm going to be fiddling around with these terminals anyway when I work on this capacitor, so I might as well change this resistor too. 30. Let's just verify before I go any further. I'm going to nip one end off right here. And you know, I'm going to put a, because I know myself, I'm going to put a clip lead on that spot, so I can't forget where it came from. Now the resistor is free on one end. We can be a little more certain about its reading, but I bet you it's going to read exactly the same. Yeah, 410. Okay, well, we'll put in a nice 330 ohm resistor there. Let's, hey, don't stop. Let's take the capacitor out. And we'll test it. So the weather has gone crazy. Yesterday was sunny and 30 degrees, hot, humid, sticky. Then, you know, thunder showers in the evening. And today it's cold, gray, rainy. Actually the sun has come out, so I shouldn't really say that. But totally different. Tonight the temperature is going to go down to 6 degrees here. Wow. It's a seesaw of weather. 50 volts. Will be eye closed. So it opened almost all the way, but not quite. 150 volts. Like all the rest, it's not opening at all. So it is leaky, but as I said, I just don't think it's that critical a thing. Okay, so I'm gonna get a resistor, get a capacitor, stick them in there, and then we'll try the radio and see what happens. Oops. A little piece of solder fall through the radio there. Ooh, what's that sizzling? I got a sizzle. Nothing in there should sizzle. May have been some of this old black insulation may have sizzled a bit there. It's a little odd. Okay, so I got the new capacitor, new resistor. Are they really in there properly? Make a short circuit here. It's quite a piece of excess wire there. Let's see if I can get it. Okay, we're ready for a test. Kind of shook things up there. So again, I don't expect today's efforts to have made much difference, but you know, a little bit of incorrect bias on this tube and a few other dilapidations. Maybe all in all, it was affecting the performance. Okay, we're plugged in, switched off. Okay, power on. Dim bulbs in the circuit. Here we go. Okay, full power. I think Niagara Falls is running pretty hard these days, so yeah, really strong electricity. So the last thing we were tuning was the French station. The string is vertical. We're near the French station. There he is. That's pretty good. Okay, we'll try the other 3 or 4. Let's start right with that close because I can figure the station's better that way. First one should be 590. I'm starting to get a good impression of the speaker. The speaker is good. Sounds good. 590. $640. So this is a good test now. So 680 is a station with a noise signal about maybe 3 kilocycles above it. A fairly narrow, a similar strength noise signal. It just happens to be the way it is in my shop. Each time I tune in 680, I'm finding out how well a radio can select 680, ignore the noise that's just off to the side here. This radio's doing pretty good now. There's 680. Here's the noise. There's definitely an overlap of the noise and the signal, so it makes it a really excellent test spot for a radio like this. Okay, COVID-19 in Brazil. There's an example of what happens if you don't do anything, or you do very, very little. Yeah, Brazil. Okay, I think that's it for today. I'm just doing a little bit each day because it's still too nice to be in the shop, even though it's kind of bad outside. I still like being outside, so that's great. What do we got left? We got 2 or 3 capacitors left on the audio side of things. Then it's time for another realignment or alignment, and then we see what we got. I think it's going to be pretty good. Great, thank you very much for watching today, and I'll see you on the next video, probably tomorrow. Oh, okay, change of plan. I went to make the video is so short, I haven't been here very long today, so let's do another capacitor, continue with the idea that we're doing the RF capacitors, and there's one right there, I'm pretty sure. So this will be the other one I will do today. This one is right in the middle of the IF area, pin 7 on this tube, and connected to pin 2 down here. Pin 7 on the 12BA6 RF amplifier tube. Pin 7. Let's look and see what we can find. Pin 7, eh? Okay, pin 7 on the RF tube. That's this guy. My gosh, look, there it is right there. Oh, it's another bypass. Or is it this one? No, it has to be this one, off of pin 7. It has to be this guy. 200 volt only. Did they do that over here too? Let's just look, the one I replaced. Yeah, it was also only a 200 volt because the pressure on these capacitors is extremely low, just a few volts. Why spend all the money for a powerful 600 volt capacitor when you can sneak a 200 in? Okay, so I'm going to put a powerful 600 volt one in here anyway because that's all I have. 0.05, and then we got this resistor. Let's do the same thing. We'll find this resistor, see what its value is, consider replacing it. 10%. Now there's something that gives you a hint. They didn't do a 10% one here. So what this really means is they put a fairly precise resistor in here, which means they were quite concerned that it'd be very close to 56 ohms to go in here. Okay, so that's important. Okay, so too many okays, Jim. Let's go back there and we'll check it out. Okay. First we got to find it. Well, it should be traveling right with this. I don't think this is that capacitor. Okay, let's find the resistor anyway. It's got to be this one right here. Green, blue, black. It's a fair size, like it looks like a slightly larger resistor for higher wattage, and they've elevated it on its leads. See how it's standing up here quite high? Of course, a lot of these are standing up, but all those things are indications that maybe they expect this to run a little warm. So let's measure it. 56. My lead's right here. That's handy. Okay. Well, can't complain about that. 54. That's good. Now, what about the capacitor that's supposed to be across it? So there's a black wire coming up the back here. That's probably a B minus wire connecting here. So this is the B minus. This is the B minus point here. So this is the live end. This capacitor's on it. Maybe this is a B minus point over here, and they've just used it for convenience. An awful lot of stuff hooked up to it, but I don't see a black wire down here. Oh, wait a minute. There's a bare one that jumps over to this terminal. Yeah, I made my meter so dizzy he fell over. So bare wire coming across to a terminal, and this black wire is hooked up to it. Is it? Is it? Really? I don't think. Yeah, actually. Okay, I got it. These two terminals are bonded together, black wire going to them, and then there's a bond coming over to this terminal. This capacitor is hooked up to it. So this is definitely going from one side of this resistor to the other side. It's just taken the long way. So I could why wouldn't they put it right across the resistor? Because of this beautiful space here for it. I think that's probably why. And in the size of this capacitor, make it a little bit awkward to come across here. But the replacement won't. The replacement can go across. Okay, that's good. No resistor change, different capacitor in. Good. Yeah, I stopped the camera there for no valid reason. Okay, I'm going to cut it out and we can test it. .05, 200 volts, 0.047 actually. Okay, let's take a look. Can't imagine this is going to test any different than the others. The others all kind of pass on 50 volts and fail at 150. It's kind of okay, so 50 volts on the eye. It opens not quite all the way. They're exactly the same. These are all in exactly the same condition. So he's out and a .05 going in like this. Okay, so I'm going to install this capacitor and we're going to run the radio one more time. just one more leg to solder here. So ended up putting this capacitor pretty much where the other one was. Let's see if we got it here. Okay, that's good. There we go. Okay, another capacitor done. This one conspicuously leaving here just goes to this. So I'm just leaving it for now. It's not an element in the operation of the radio. I'm pretty sure. Okay, ready for another test. Okay, ready? Here we go. Well, I put that right on without the dim bulbs this time. Woo, risk taker. This thing had a really bad short in it, and my house fuse didn't work, and the pole transformer fuse didn't work, and the station breaker didn't work, and the big transmission line didn't work. You know what would happen? The big rotating generators at Niagara Falls would screech to a halt. Can't have that happen. Okay, what do we get? Let's go right to the end here and come back. There's a station in between here I don't normally get. I think that's 740. It's really good. It's good, good, good. Now, the French station. Shame on me for not knowing how to speak or listen to French. Shame, shame, shame. Years and years of schooling, Canadian schooling in French, and I'm useless. And so was everybody else who took French in English school. Terrible. Okay, that's great. Seems like every little change I make causes a little bit of an improvement, but it's just anecdotal. I'm not putting instruments on it or anything like that to know for sure what's happening, but I mean, it can't be getting worse, can it? So fantastic. What's left now are just some capacitors in the audio circuits, if I'm correct, and then it's alignment, and then we see what we got. Great. Okay, now I really am done for today. Thanks for watching, and see you probably tomorrow.